Hello everyone, today we'll look at how to uh, create these basic views. So this is a more or less a theoretical session. So I'm going to look at the fundamentals of technical drawing. So we are going to start with the fundamentals, starting with x, y, z axes. So we have x and y and z, and we have the minus directions also, minus x, minus y, minus z. And depending on the xy, so from these xyz axes we can generate xy, yz and xz planes. So we have basic three planes, and these three planes are the planes which are going to be used in our drawings. This is more or less your top view, this is the right view, and this is the front view. So now we look at the theory. So if you keep an object like this in the origin, so if you look at from the minus y direction, it's called the front view, and if you look at from x direction, it's called the right view, and if you look at from the z direction, it's called the top view. So we have three basic views. So what we can see is going to be projected onto a paper. Those projections are called orthographic projections. We directly look at this object, we don't look at an angle, so that's why it's called orthographic. And these are the views we can see when you directly look at the object. So when you look at from the top view, you can nicely see this uh, rectangle shape and these two rectangles, but you can't see this depth. So in this view I can't judge estimate the depth from here to here. But if you look at this view, right view, the depth is clearly visible, but you cannot see this depth. This depth is invisible. So, and the front view also, you cannot see this depth. So you can clearly see this L shape and the rectangle shape. So actually you need all these three views to get the full picture into your mind. So these three views are going to be projected onto a paper, and it's called those are the orthographic projections. So this is called the top view, front view, and the right. So all these are generated from a single model, and these lines are parallel to each other. So you cannot place this right view somewhere else, top view somewhere here. Then there is no meaning for this model. So you have to have these T rulers and offset tools and draw this according to theory. Then you can project these into a cube even, and this is the front view, top view, and the right side. So this cube can be now unfolded like this, so you can get the top view, front view, and right view like this, similar to the picture here. Apart from this top, front, and the right view, we have back view also. So front view has the rear view, back view, top view has the bottom view, right view has another offset view called left view. So normally we don't represent left, bottom, and the back views in our drawings, but if you really worried about the other views, it can be drawn. So normally we draw front view most of the time, because the front view will carry lot of information. So these three views, if you draw these three views, top, front, and the right view, it's called the that projection type is called third angle projections. And if you draw this left, front, and bottom view, normally it's called as the first angle. So now every projection method will have this front view as the main drawing. So you may have seen these kind of symbols in drawing papers. So especially manual drawings, they use these symbols to let the reader knows about let the reader uh, get an idea about what is the projection type the writer has been used. So this is called the first angle, third angle. So you see only the pictures have been flipped. So normally in our country, in Sri Lanka, we use third angle projection. Depending on the country or the discipline you are working, you may use different projection methods. Now come back to the theory again. So if you have hidden the holes or something like hidden drawings. What are the views we can see? So what can we see? So if you look at the front view now, this is like a groove. You see this depth? No, you cannot see. If you look at from the right view, you can't see this hole. It's like a hidden view. If you look at from the top view, you cannot see this hole. It's also a hidden view. So I'll show you the projections. So the front view, we clearly see this hole as a circle, and this depth also can be seen as a two parallel lines. And from the right view, you cannot see this hole. It's a hidden line, and this slot shape is also cannot be seen. So the boundary can be only seen as a hidden line. So if you look at from the plan view, you can clearly see this cut, but this hole cannot be seen. So you have hidden lines in this drawing. So when you project this into a paper, these are the views we can see. So this hole is nicely adjusted with the aligned with these hidden lines here, and this slot shape is nicely aligned with this, and this hole also nicely aligned. So you have to have that alignments like very accurately when you project the drawings into a paper. Now we look at some theory about dimensions. So we have actually placed dimensions in AutoCAD. So we already know about these terms: leader, extension lines, dimension lines, arrows, dimension text. So these these names or the terminology is really important in terms of using the software correctly. And talking about some fundamental dimension rules. Now these dimension parameters can be changed from these uh, keywords also in AutoCAD, but we didn't use these commands. Early days people actually use these commands to adjust the parameters. So now we have the GUI, so there will be no problems. Now when it comes to dimensioning, you can use these dimensioning methods, such as putting the dimension inside the view. So this is not a mistake. This is 100% correct. So you can place the dimensions inside the view, but you can't have these crossing dimensions in a drawing. This is incorrect. So please remember these fundamentals in dimensions when you start working with your own drawings. Now we look at the next rule. So if you look at dimensions, these parallel dimensions are 100% okay, no problems. This is okay. And you can have the dimensions text with aligned with the dimension arrow. So this is quite okay, but this is not really good in terms of viewing, but it's not incorrect. This is perfect. Horizontal dimensions, this is also acceptable, but it's not incorrect. Then we have dimension text horizontal. So here everywhere the dimension text horizontal. Sometimes, as previous case, dimensions text align with the dimension line can be also used. And here dimension is above the dimension text is above the dimension line. This is also correct. And continuous dimension, so we can have this kind of dimension. These are called continuous. Actually I told you in the class previous videos, don't use this in production drawings, because if you make a mistake here, rather than that mistake will be accumulated to the other places also. And this can be and we can use the parallel dimensions also. If you have something like a hole, for these two dimensions are called parallel. So if you don't have an idea about symmetricity, just have this parallel dimension, no problem. And never dimension to a hidden line. So this is incorrect, because they have dimensioned the hidden line. So normally we don't use this. Always dimension to a clear line like this. And it says dimension should be given where they are obvious. So this is incorrect, because this dimension is given to a center line. So dimensions we should not give given to a center line or a hidden line if it is not clear. So this is good. These lines are clear. Line is not clear, reader cannot understand it clearly. So this is incorrect, this is correct. and the dimensions must not be repeated. So it's 2 here, 2 here. So this is easy to read, but in terms of production, this is incorrect because the manufacturer is having a confusion whether to use this dimension or this dimension to manufacture, because there's an error always with the manufacturing. So if he uses this method and try to cut this, get this shape, or and if you use this dimension and try to get the shape, there may be small deviations in the actual part. Then when dimensioning, consider the machining process. So if you are working in a mechanical drawing, you have to always look at how the machining process is being done. According to machining processes, you have to give these baseline dimensions. Normally we practice these baseline dimensioning schemes. So you have to look at how the lathman or the other manufacturer is using your dimensions in order to produce your part. And this is called a reference dimension. Actually no need. This is just to get an idea only. Don't use this dimension for actual manufacturing. So if you see a dimension within brackets, so in gray colors, light colors, those are reference dimensions, weak dimensions. Then here we have 3 1 1 1 again. This is not acceptable because 1 1 1 is also 3. This is also given 2 3. So you can make this, we can omit this dimension or make it a reference dimension or a weak dimension when manufacturer is not in a confusion. And when it comes to hatching, normally we don't hatch the text. So you can see the text is omitted in the hatching area. So normally we don't we don't cover the hatch text with the hatch. Then it may not be clear to the reader. The text may not be clear to the reader. This is good way of representing. And when it comes to diameter dimensioning, you have to always have this diameter symbol preceding the figure always, and this is recommended. This is not incorrect, not recommended, because this dimension is now at an angle, so it's difficult to read it. It's not very appealing, nice looking, professional, not professional. So this is also not very good because the dimension has been given to a center line and somewhere in the quadrant. So have the dimension in an area like this, which is very clear to the reader. Then when it comes to chamfers, you can use these methods: angle, distance, distance, or else in SolidWorks and other softwares this method is also applied. In writing you can have the word chamf and give the angle and the distance. And when it comes to drawings without not according to scale, you can have this the underline, which indicates when you measure from there to there, that 12.5 is not there. So 12.5 is not coming from a ruler. So these can be measured from a ruler, but 12.5 cannot be measured from a ruler in an actual hard copy. And when it comes to a ball circle, these are the ways of representing. We can give angle to one instant, and the BCD circle diameter, and the diameter of one instant, and how many instances. So those are the fundamentals of dimensioning. Now we'll quickly look at what are the fundamentals of sections. Now we'll look at the theory behind the sectional views. So why we need sections first of all? So when you try to draw an object without sections, what is happening? So now there is some cut inside this cube. So if you look at from the front view, this cut is viewed as a hidden geometry, but you cannot visualize whether this is a circular shape or a say square shape. So there is no idea if you don't present the top view. So that's why we we have to scan this object like cutting two sections. So this is now this object is cut from the middle. So when you cut from the middle and remove this area, and when you look at this now directly, you can clearly see this shape, as well as you can have an idea whether this is round shape or a square shape. So why we hatch this now? So this is called hatching. Why we hatch? So whatever we can see clearly, we are going to hatch. So the other, if you don't hatch the other area, that means this hatching area and this unhatched area are not aligned. So this area should be behind the hatching area. And if you look at the these lines, these boundary lines are now continuous lines, because you can clearly see these boundary lines. But if you look at this front view, these are hidden lines because you can't see it. So here we can clearly see these boundaries, so that's why these lines have become continuous lines. So when you hash this, another important message is conveyed. We Depending on the hash pattern, the reader can understand the material you have used in this part. So every material has different hash patterns, so it's very easy to get an understanding. So if the object is a symmetric object, you don't need to provide full section. You can have half section. So you can cut only half of the model and look at from this area and draw only that. So we are going to draw that part. Other part is still hidden. So you can clearly see the boundaries. This is hidden. These are hidden lines. These are continuous lines, because clearly you can see the boundaries. So why we draw this part again? Because if it is a symmetrical object, you don't need to draw this even. So you can have something like this front view in half section with the hidden features not drawn. So we don't need to draw this. So don't get confused if you see this kind of a section. That the idea is this is a symmetrical section. You can't see the left view, but it's a symmetrical section. Then we can have this kind of a weaving also. This is called broken sections. You don't need to represent the full section details. It is more or less symmetrical and the information is obvious. This can be also drawn. And this is called a revolt section. Why we use the revolt section? The top part is like IB, so we can't see the I section clearly if you don't draw the plan view. So drawing a plan view is unnecessary in this kind of drawings, because it will not carry a lot of information. But if you want to say the reader this is made of I section, what you can do is you can rotate this plan view and 90 degrees and show it to the reader like this. You can cut it from here and rotate the plan view and show it as another view. This is called revolve section, and this revolve section can be drawn in somewhere other place, that is called remove section, something like this also. Then we have offset sections. The theory behind offset section is to just cut it in from the middle, these circles will not going to be cut. So if you want to show all the information in one drawing, you can cut it in different places. These different cuts are called offset cuts, so offset sections. So this will reduce your offset section views. So if you have 3 separate cuts, you have to have 3 views separately drawn, but here from a single view all the information is going to be covered. And but mind you, if reader should understand, these are not in the same plane, so this is offsetted. So please when you give these kind of drawings, at least you have to give 2 views to the reader, otherwise reader may be in confusion to understand this. And there's another view called align sections. Normally we don't use this in these days in AutoCAD and manual classes, but in SolidWorks it can be automatically generated. So this section is cut at an angle. If you take my SolidWorks notes, clearly mentioned. So if you want to give more details to the reader, you can cut. If you cut just vertically, there is nothing to show. If you just cut vertically, the appearance may be show you this kind of a appearance. So there's nothing to show in this area. It's like a disabled person, so handicapped model. So what the reader does here is he is going to cut at an angle, and this part is going to be rotated until here, and that information is going to project you. So actually this drawing is not a symmetrical drawing, but if you look at this drawing, this is more or less a symmetrical. But don't get confused. Why we are doing this is to give more information about this area. Otherwise, if you just cut vertically, this is the drawing we produce. So we cannot give a lot of information to once. We cannot concentrate a lot of dimensions into one area, so it's not going to be readable. So that's why we have this kind of symmetric drawing and distribute our dimensions nicely and present. But reader should understand there is nothing called, there's no part here. It's just a visual representation only. Then we have hatches. So hatch has normally hatch angle and the gap. So we in AutoCAD we have a different video for this hatching. We can have the angle and we can adjust the gap between the two consecutive lines. So normally when it comes to two hatches, you have to have different angles. So here we have three hatches. You have to have different angles to clearly show the reader these are three separate areas. So this is not recommended. Why? Because this hatch line is parallel to this boundary. Not recommended. Hatch line is parallel to the boundary lines. This is good because the hatch line is not parallel to the boundary line. This is also good. Hatch line is not parallel to the boundary line. And now we have auxiliary views. So we have the fundamentals, front, right, and the top. If you want to show more information in architecture, this may be heavily used. Say this is the roof of a building. So if you want to show the roof information clearly, you have to generate a auxiliary view. That means you are directly looking at this slanted plane, and you are going to draw whatever the things you see in this plane. So this is called auxiliary views. So in order to do auxiliary views in AutoCAD or manual classes, we have to project like this perpendicular to this plane and draw whatever the things you can see. But be careful when you have holes in the holes in this plane. So when you look at from the front plan view, you cannot see a hole as a hole circular shape. You may see an ellipse shape because this is at an angle. So if you look at from the right view, also you cannot see the circular shape clearly. It may be shown as an elliptical shape. But if you look at from the auxiliary side, this view is clearly seen as a circle. So remember these fundamentals. If you want to see a circular shape as a circle, you have to directly look into that. Otherwise you will see ellipse shapes. So that's about technical drawing theory. So we have a tutorial based on these things, so you can try these things. Actually we did this. You can draw the projections in AutoCAD, and here also you can draw the projections. Look at these areas and draw the basic three projections. And here it says cutting plane passes through the hole, so you can have a cutting plane here and draw the things you can see. So these kind of exercises may be given in the exam. So we'll give you a 3D model like this and ask you to draw the front view. We'll ask you to have a section and draw whatever the things you can see in the AutoCAD. So practice these questions and get an idea. We'll try to upload the answer for this question in the coming videos. So thank you for watching this video. Next video we are going to talk about isometric drawing. So see you there. Thank you.